I only have one message to give you. I don't care what you think of me. I don't care what you call me. I do care what you do with this information because it is important to our survival as a species.
A secretive Pentagon agency known for breakthrough research is on the front lines of the fight against the coronavirus. It's called DARPA, the Defense Advanced Research Projects Agency. CBS's senior investigative correspondent Catherine Herridge takes us inside.
DARPA, one of the Pentagon's most mysterious agencies, is usually hidden. You won't find any signs outside its headquarters in suburban Washington, D.C. But Pandemic Prevention Platform Manager Amy Jenkins told me DARPA inventions are all around us. Everything from Siri to stealth technology to self-driving cars, even your phone's GPS. Now, with hope of a coronavirus vaccine still uncertain, DARPA is zeroing in on something faster.
It's like a temporary fix for COVID-19.
A temporary fix. It's meant to put up fire break around the pandemic.
By sifting through the blood of COVID-19 survivors, DARPA hopes to identify and clone the genetic blueprint of the most powerful 1 to 3 antibodies that best fight the virus.
We aren't allowed in the Maryland labs just yet, so this is video given to us by the Department of Defense.
Regrettably, because one seems to come, every year or so, we're getting very good at this.
Here's where that work stands right now. Scientists say they are looking into how mice respond to potential vaccines. They're not examining if they protect against COVID-19 yet, but how mice respond to them. Officials believe the earliest they'll have a vaccine for the public is 12 to 18 months. It's complicated, but here's the simplest breakdown.
Think of this as the virus, my fist, it's a sphere, right? And it's got little spokes coming off of it. That makes it the corona. When you look at it on cross-section, it's got that crown look to it. So almost all the vaccine candidates out there are focused on that little spoke.
Once they figure out how to prevent that spoke from attaching to the body, that's what will make for a good vaccine. This is not new research. These scientists were the first to test the Ebola vaccine. Malaria drugs came through here. It hasn't always been easy. Last summer, the CDC shut down the lab at Fort Detrick because of structural defects. The commander says there was never any danger to the community, but changes had to be made, and the lab was restored last month. Now they're able to work the coronavirus at all levels.
The Joe Rogan Experience.
You know what one scared me more than anyone that I've ever read? I read about this thing that DARPA was putting together. It's a robot called the Eater robot, EATR robot. It's a robot that fuels itself on biological matter. So it essentially could eat bodies.
These are microbial fuel cells. And we have, if you like, 2 compartments on this, an anode and a cathode, a little bit like a battery cell. And this contains microbes. And we feed those microbes with all sorts of different types of foods we can use.
You have to solve the same problems that animals do and animals eat. And of course there's a lot of plant material around, there's a lot of insect material around which they can use. The robot, of course, moves very, very slowly, I have to say. But you can put one fly in each of these microbial fuel cells, and it'll go on for maybe 4 or 5 days. There's enough power, and it will move at this sedate speed of 10 centimeters an hour. But it'll carry on for that, for 5 to 6 days.
You've got a murderous robot that eats people.
It's like
That's its fuel.
Worst kind of things that human beings could achieve. It's like people are sat around trying to come up with them.
Well, they're responsible for a lot of really crazy innovation in terms of like military stuff. But Boston Dynamics, they're the ones that make those crazy robots, and they work with DARPA, and those are the ones that make those robots that you can't kick over.
Right.
That's what you need. One of those that eats people, and you send them to the battlefield.
Kick it over! No, that's the first thing we established, is you can't kick it over.
I just think that's the big fear, is that future warfare will be our robots versus their robots,
Extraordinary. Visionary. Transformative. Today, DARPA delivers new capabilities to our warfighters, new ways of responding to threats to our country.
Welcome to Voices from DARPA, a window onto DARPA's core of program managers. Their job, to redefine what is possible. My name is Ivan Amato, and I'm your DARPA host. I've been away since the end of 2018, and I'm excited to resurrect with this episode the Voices from DARPA podcast. However, I do this at one of the most trying times most of us can remember. Everything seems to have changed. Nothing feels right. On March 11th, one of the days on which I sat down with program managers in our recording studio, the World Health Organization, WHO, declared the infectious spread of the coronavirus as a pandemic. COVID-19, the disease caused by a new coronavirus that scientists refer to as Severe Acute Respiratory Syndrome Coronavirus 2, or SARS-CoV-2. It has been among us at least since late last year, when the first cases showed up in China. And now you and I and our 7.8 billion human brethren are living in pandemic times. The world's people are in this together.
Hello, I'm Colonel Matt Hepburn. I'm a program manager in the Biological Technologies Office at DARPA. I am an active duty Army infectious diseases physician and have specialized in addressing biological threats that can either be engineered or naturally occurring, such as Ebola or pandemic influenza. Addressing biological threats that can either be engineered or naturally occurring, such as Ebola or pandemic influenza. Today we're going to be talking about one of the technologies that I actively manage, a company called Profusa, which is aiming at achieving tissue-level continuous health monitoring. Through the SBIR program, we funded them to solve an incredible technical challenge that no one else had been previously able to solve. The key innovation that was presented to us is they said, why can't we make a chemical substance that's really identical to what's underneath the skin, what we call the subcutaneous tissue, so that your body doesn't recognize it as a foreign body response. It just incorporates itself into the tissue. And we have a lot of examples now where a sensor put right underneath the skin can sense things like oxygen and other chemicals that are very important to our metabolism. And not just sense that for a day or a week or even a month, but we imagine that sensing these parameters can go on for a period of years. One of the most important applications to us is so that we can improve the health of our worldwide deployed military force. We feel a strong sense of obligation that if we're going to ask somebody to be deployed and to carry out their mission, that we want to keep them healthy. And this technology will give us a way to monitor if someone is getting sick. We imagine that we would be able to sense that very early and therefore prevent them from getting sick and prevent their complications, allow them to stay healthy and continue to carry out their mission.
After World War I, multiple state governments launched their own biological weapons programs as a research endeavor and stockpiling countermeasure.
And that's probably one of the most top secret
pieces of our former bioweapons program is that formulation of how you keep these things stable to survive as a weapon. These things are living organisms, so they are very finicky. In the Soviet biological weapons program, they tried to create a plague bacteria that was resistant to several different antibiotics. They created this super duper plague weapon, but actually it was a horrible weapon because it would just die. They couldn't have it survive in the environment.
With this focused experimentation, scientists ended up creating enough bioweapons to kill every person on the planet. But luckily, national governments signed a treaty to ban biological weapons. Decades later, huge investments in genetics made the tools and techniques cheaper and more accessible, enough for it to be possible to create an engineered synthetic pathogen. And that's why SynthBio and its quest to make biology easier to engineer set off alarm bells.
In 2002, a group of scientists from the State University of New York at Stony Brook created the first artificial poliovirus synthetically, not using any natural viral components. So that was a real radical innovation. At that time, a congressman picked up the New York Times that day, read about this artificial synthesis of the poliovirus, and really got freaked out. Then a lot of other federal entities got concerned about what happened here. Did we slip up? Should we have done more to have oversight over this?
This poliovirus study was actually funded by DARPA, an agency within the U.S. government.
Addressing biological threats that can either be engineered or naturally occurring, such as Ebola or pandemic influenza.
Project GreenVax is a research and development project sponsored by DARPA to demonstrate the capability of an unprecedented response to any future or current pandemic. Specifically, the goals of this project are to demonstrate the capability to produce at least 1 kilogram of purified vaccine protein, which equates roughly to 10 million doses of vaccine protein within a single month. And more importantly, not only can you make 10 million doses within a month, but it would take only a few weeks to switch to a new strain. An important component of Project GreenVax is scale. It's very important that plants can make effective vaccines, but if you could only protect a few thousand people, that would not be useful as a strategic resource. So scale up was really critical. Scale up not just to a regional scale, but to a national and global scale.
DARPA wants to take the concept to the next level.
We have said, rather than doing this in those big bioreactors, let's turn our body into the bioreactor.
In upcoming clinical trials, they hope to inject people with the genetic code.
It's the blueprint for the antibody, and then the cells take up the blueprint and they're able to produce the antibody themselves.
Unlike a vaccine, investigators say these antibodies could provide protection within hours, not weeks.
We're not teaching the body how to fish, we're literally giving them the fish.
With about 1 million Americans infected and more than 50,000 dead, DARPA hopes their project could provide temporary protection in time for an anticipated second wave for high-risk groups.
Our healthcare workers, our frontline first responders, and then even potentially maybe the close personal contacts of those who are infected.
But DARPA's primary mission is safeguarding U.S. troops who often deploy quickly to global outbreaks.
So I don't want to use the word opportunity, but in some ways this is an opportunity for us to make sure we learn all of the potential lessons we can learn with this and apply those lessons learned to be more prepared the next time.
There is going to be a next time.
There is going to be a next time.
Taiwan, New Zealand, Australia, they took their experience and actually prepared, and so they moved a lot faster. So we, we'll have to prepare for the next one. That, I'd say is will get attention this time. The idea of a bioterrorist attack is kind of the nightmare scenario because they're a pathogen with a high death rate would be ticked. Now, the good news is, I'm not trying to depress you, it's tough enough right now, that most of the work we're going to do to be ready for pandemic 2, I call this pandemic 1, most of the work we'll do to be ready for that are also the things we need to do to minimize the threat of bioterrorism.
On the timeline, the scientists we spoke to said they hope to have identified the best antibodies any day now and start clinical trials as early as this summer. That way, they hope to be prepared if there is another wave of coronavirus later this year, Gail.
Well, Catherine, we're cheering them on. A temporary fix sounds pretty good under these circumstances. Thank you very much.
Scientists are raising the alarm over a Defense Department research program that aims to use bugs to protect crops. The program in question is called Insect Allies, and it would look to enlist aphids, leafhoppers, and whiteflies to transmit genetically engineered viruses to crops. Those viruses could activate or deactivate parts of plants' genetic code, helping to fight diseases or resist droughts. But a group of scientists say the technology, and specifically the use of bugs to disperse it, could be easily weaponized. In a paper in the journal Science, the scientists argue if the program were benevolent, it could use spraying equipment to distribute the viruses instead of bugs. The program's manager told the Washington Post those fears were unfounded and that the program is focusing on delivering positive traits to plants. Either way, the Post points out, it's normal for DARPA projects to go nowhere, so the whole debate may be moot.
One issue that has come up is once you do have a vaccine, how do you properly distribute it? How do you get it out quickly to millions?
Well, when we have the vaccine, we have the military all lined up, and the military is going to be doing it in a very powerful manner. These are people that don't usually do vaccines. They do soldiers, and they do lots of other things that, frankly, are more difficult. But we have our general, and logistically, he's all set. Tony, do you want to say something about that?
That is correct. As the vaccine rolls out, we'll be getting them distributed. And as you probably have heard, we are going to make sure that we do it in an equitable way, and it's representative of the populations who need it the most. And we have the standard way that we determine that with the ACIP working with the CDC, but Dr. Collins and Dr. Redfield have put together with the National Academy of Medicine a group that will fortify that decision-making process, so that we're making sure that we're very fair and equitable in getting the vaccine distributed properly.
Let's just hit this right off the top. There has been a video, it's about a half an hour long, that has gone absolutely viral, called The Plandemic. And it is said to be one of the most sort of conspiratorial and widespread uses of misinformation that is on the web today, so much so that a couple of social media sites have taken it down. What's the message that the video is trying to convey?
It's infuriating. I don't know if you suffered through it, Steve. I actually watched it.
I sure did.
Every 30 seconds, there's something enraging in that video. It has a lot of the classic conspiracy theories about big pharma, about where the virus came from, the idea that it was manufactured, and yes, it has a lot of really classic anti-vax rhetoric, and this kind of stuff, these kinds of conspiracy theories, take off for a bunch of reasons. We're at a time, there's a lot of uncertainty right now. There's fear. People are looking for answers, and a video like this, especially when it's produced so convincingly, and the expert, uses data and scientific language so convincingly, can have a very big impact. It can be quite attractive. And I think that's exactly what is happening right now.
Straight out of the pages of science fiction, militarized ticks ready to kill. Not like this, riding missiles into the air, but with diseases like Lyme disease. The theory is scientists during the Cold War ran experiments on ticks and other insects to create biological weapons. And somehow those bugs got out, either released on purpose or by accident, which is why some believe we're seeing a big uptick in Lyme disease. In the last 20 years, the CDC says Lyme disease cases have gone up by nearly 300%.
With that big of an increase, it makes sense that people would try to come up with unique ways to explain that.
Right. I think it's just a conspiracy theory. I don't really see it as reality.
Janet Jarnefeld is the tick expert at the Metropolitan Mosquito Control District. She spent the last 30 years studying ticks and says this idea of turning them into weapons is hard to believe.
It doesn't make any sense to me that somebody from the military would be wanting to experiment on a creature that moves so slowly.
Researchers in Michel Miharowitz's lab at the University of California, Berkeley have developed a wireless system to control the flight of a giant beetle. A scientist sends a wireless signal from the laptop to the beetle to start and then stop flight. The beetle, seen in the upper part of the frame, is tethered for practical purposes.
Okay, let's try it one more time. Start command. Stop command. Okay.
Here, the beetle is attached to a clear plate so that its flight pattern can be better observed. An oscilloscope next to the insect shows the electrical signals as they are delivered. A short oscillating pulse triggers the animal to flap its wings, and it continues flapping until a short signal pulse tells it to stop.
So I promise you, nothing that I show you today is going to be an illusion. So with that, again, my name is Justin Sanchez, and I'm a neurotechnologist by training. And like was just said, I was at my lab at the University of Miami, and I got a call out of the blue. At the other end of the phone, there was a person that says, we need you to come immediately to Washington, D.C. and come to DARPA. And that's really where the whole story begins. So what is DARPA? DARPA is the high-tech research branch of the Pentagon. And I'm currently the office director in the Biological Technologies Office. And like many of my other colleagues that are at DARPA, my journey to the agency was an opportunity to expand the impact of the work that I was doing in neurotechnology, find new avenues that it could be applied. So the first person I want to introduce you to is Nathan. He's the one on the right side of the screen. And Nathan is living with paralysis. He was paralyzed in 2004 in an automobile accident. And Nathan was actually a freshman in college. He was studying nanotechnology. And when he heard about some of our studies, he said, I want to be a pioneer in that. So he signed up to do one of our studies. And Nathan had that same array, right, that 4x4 millimeter array, placed in his motor cortex, right, the part that is involved in movement. He had another set of arrays placed in his sensory cortex, okay? And you can actually see on the upper right side of the screen there's a little plug that's coming out of his head. That's where those arrays are connected to. And the wires send the signals from his brain actually to that bank of a rack of computers in the middle of the screen, process all of his neural activity in real time, and actually send that activity to that robotic arm. We also developed the robotic arm, and he met President Obama, was able to think about moving the robotic arm, and shook the president's hand. Okay? Now, the other part of this story is that that robotic arm also had sensors in the fingertips. So when the president placed his hand on the robotic hand, the force transducers took that information and did the reverse, went back through the computers, went back through the wire, back into Nathan's head, and he could actually feel the president's hand on the robotic hand. It was truly a remarkable moment. All right, so that's Nathan. The next example I'd like to show you is a person, his name is Doug. Okay, and Doug was injured 25 years ago in a near-fatal electrical accident. And Doug's very different than Nathan in the sense that he has no hands on both of his arms. He lost both of his hands. Imagine living your life that way. But for Doug, we also explored the possibility of a direct neural interface for him. So in this particular case, it took that same sensor array, but instead of placing it in the brain, we placed it into the nerves of his forearm. So in this particular case, it took that same sensor array, but instead of placing it in the brain, we placed it into the nerves of his forearm. And you can actually see on the right side of the screen there his residual limb, and that's where that sensor array is.
This required all new innovations across the board. First of all, most processes that occur in a laboratory just won't scale. You just can't get there from here. So we had to design very innovative new processes for purification that would be cost effective and could scale at the global scale. And conventional lighting systems that you may see for a grow light to grow a strawberry in your house just doesn't work for millions of plants. They're very, very inefficient in terms of their photon dispersion on the plants, but they also produce a tremendous amount of heat. So we came up with the first ever light-emitting diode, an LED solution that optimized the wavelength of the light specifically for our plants, and provided almost double the amount of photons on target. We had to innovate how the bacteria that actually delivers the gene of interest in the plants actually gets there. And then, of course, the downstream portion is highly innovated by our modular manufacturing facilities. These are unique in the world, the first of their kind, and they themselves were sponsored by DARPA funding to create the world's first modular clean rooms that are actually mobile. They can be moved around on a cushion of air, just like an air hockey puck that a person might play. And then when they're set, they could be set into place, but when they need to be moved or changed out to provide flexibility, the air bearings inflate the entire 20,000-pound room, and you can be moved and replaced. So there's innovation throughout this facility. All of that needed to occur in order to make this successful. And of course, DARPA sets the bar very high. If it were easy, DARPA would not be doing it. So this was not just hard, but in the words that DARPA uses, this was truly DARPA hard.
My friendship with Nick Rockefeller was one where we expressed ideas to each other and thoughts and philosophies, and he wanted me to become part of what they were doing, and for me to become a member of the CFR, and offered various business opportunities for me to get involved in, and for me to not take up the fight or the battle that I've been taking up in the past, to drop that idea, because what was the point of my fighting for the people, right? So I had a friend, Nick Rockefeller, okay, who was one of the Rockefeller family, and he, when I was running for governor in Nevada, he came to me, introduced himself to me through an attorney, and we became friends. We started talking about things, and I learned an awful lot from Mr. Rockefeller. And one of the things that we used to talk about was the ultimate plan of the banking industry, what they wanted to accomplish. And the goals of the banking industry, not just the Federal Reserve System, but the private banks in Germany and England, all over Italy, all over the world, they all work together. They're all central banks. And they're all part of the Communist Manifesto. Central banking is one of the major planks of the Communist Manifesto. We talk about America being a capitalistic country, but yet at the same time we have a central bank that plans everything for us, right? And the graduated income tax is another plank of the Communist Manifesto, right? So right there you have two major planks of the Communist Manifesto that have been brought in because of the Federal Reserve System, okay? So the ultimate goal that these people have in mind is the goal to create a one-world government run by the banking industry, run by the bankers, and they're doing it in sections. The European currency, the euro, and the European Constitution is one part of it. Now they're trying to do it in America with the North American Union, right? And they want to create a new currency called the Amero, right? And the whole agenda is to create a one-world government where everybody has an RFID chip implanted in them. All money is to be in those chips, right? There'll be no more cash. And this is given me straight from Rockefeller himself. This is what they want to accomplish. And all money will be in your chips. And so instead of having cash, anytime you have money in your chip, they can take out whatever they want to take out whenever they want to. If they say you owe us this much money in taxes, they just deduct it out of your chip digitally.
Total control.
Total control. And if you're like me or you, and you're protesting what they're doing, they can just turn off your chip.
As more and more businesses begin to open their doors across the UK, shopkeepers are increasingly looking for ways to ensure the chances of COVID-19 spreading are kept to a minimum. One measure being widely employed is banning the use of cash, instead asking customers to reach for their debit or credit card. Like many businesses across London, Cafe Donata has ditched handling money for the foreseeable future.
We know it's very important for customers and staff to feel safe. So one of the first things that we did is to say we're going to go cashless. It all has to be paid by card. And because our value of our product, each transaction value is normally between £5 to £10 on average, cash contains so many germs. When you're touching cash, it's a known fact. that notes and coins, and they carry a lot of germs. So it makes it a lot easier. It reduces the contact between staff and customers.
Well, health experts say the coronavirus can live on surfaces like cash for up to 10 days. That has many people worried about shopping and other everyday tasks. Action News reporter Dan Cuellar covering this angle for us tonight. He's in Bala Cynwyd at the shopping center with more on this. Dan.
Shari, it is raising new concerns for people handling cash and why they should be taking precautions to be on the safe side.
The no cash sign outside a St. Paul liquor store is hardly unique. Chains like Noodles & Company have stopped accepting cash entirely during the pandemic. Even Whole Foods now has specific lines with the no cash option. Other stores and restaurants are simply discouraging cash and sanitizing heavily anytime a customer pays with dollars or coins.
My policy to all the employees is if you get a cash transaction, go ahead and accept it. I ask that the customer set the money on the counter so there's no hand-to-hand contact at that point.
At Nokomis Beach Coffee, co-owner Dennis Klock says employees are also washing their hands after every cash payment.
I think we have it set up, a system in place that a customer shouldn't have to touch anything when they come in.
But Klock says cash payments have dropped from 35% of daily sales to less than 5% during COVID-19.
It definitely is accelerating the trends.
Michael Reed runs the payment division at Deluxe in Shoreview, which is helping businesses adapt to COVID-19 with online payment systems.
A lot of people don't like to hand the money back and forth. They don't want to hand their credit cards back and forth. So finding ways to transact in a frictionless way that doesn't require those interactions are definitely on the rise.
Cash. When was the last time you used it? The coronavirus pandemic and lockdown has meant that many people are using card or contactless more than notes and coins to pay for things. Research from Nationwide suggests that people have gone an average of 44 days without using any cash at all. So, is coronavirus turning us into a cashless society? And are we ready for it?